Yes, so we are here again for um, this class on machine. I'm trying to explain essentially how a linguist can develop um, a machine dataset. How linguistics dataset can be um, something Gabas. Can you mute yourself? Aisha. Oh, I think everything is done now. I'm wondering because um so what I want to do in this short class, I hope it is short enough. I'm sorry, I'm trying to use my phone to join my other system actually to join so that we can. Should it be the case I want to quickly write something, um, I can write. So my goal in this particular class is to show how linguistics data are generalizations of um, are generalizations that machines are trying to learn from big data. And essentially, what I'm trying to do, hopefully, is to show that um, um, sorry, is to show that everything machine is trying to do from a large data set is actually a finite pattern that linguists have developed. So having said that, we'll dive straight into it. Give me a minute. I'm trying to set up this particular laptop so everybody can see that when we are done. So why? Okay, sorry for the delay. Um, so what is data? I love to talk about data a lot because data is the oil and gas of every AI project that you see, regardless of whether it is language related or nothing. Because machine learning, we're meant to learn from data. So machine learning simply means learning from data. So if learning from data is what machine learning is, then data is the way we go about machine learning. And without data, we don't have machine learning. Okay. So in this case, what is language data? What is data? So the communication of human knowledge system through forms and signs is what I would define data as. How we communicate human knowledge system as through the form, the sign, the multimodal process. So what that means is that data is not just sentences. Data is not words. Data is not phrases, as an NLP engineer would define them. Data is a knowledge system. And why is it a knowledge system? When we are communicating to people, which is how we get data, the elicitation process you are saying, we are trying to realize the thoughts of native speakers of a language. So when we have data, data is not just like these sentences you are looking at. It's deeper than that. The data you see on the surface is a behavioral pattern communication. It's trying to show how the belief system of a specific group of people is communicated. And if everybody know their language, We don't know they know their language until we can see what they know about their language. To some extent, we can approximate and abstract that, okay, this is about what these people know about their language. All right. So it is a structured process. It is systematic. It can be speech, it can be text, it can be science, it can be multimodal. And as you can see from what Professor Akimbo explained yesterday, the best mode is the multimodal mode, because with the multimodal mode, it entails others. So you can do speech with it, you can do text with it, you can get science with it. So don't forget, data is what? A communication of human knowledge. So it can be in different forms. It can be in text, it can be in speech, it can be in science. But very importantly, it is not just text, it is not just speech, it is saying something important about human knowledge. So what is linguistics data? It's a list of knowledge systems that we extract during our elicitation process. Why the canonical reason is usually to analyze and to summarize the minds of native speakers. We are representing the thinking pattern of these people in a body of knowledge. For example, if you are trying to understand the pronoun system. Pronoun is not just pronoun. Pronoun is an identification. If I say, did you, if you have read how to act with words, did you eat the food? The person is not asking you a question that does not have implication. If I say, did you eat the food, and you know that there's a penalty for the person that is eating the food, you know that you can't admit that you ate the food, because if you did, then you would be uh, in troubles. As I add, if you're on this call, please, there are this OAI note taker that Chomsky is trying to fight, but they are repeated. So it thought that they are. Can you remove them and not join? Let them join.
Yes, I'm on it.
Thank you.
Okay.
Okay. So more importantly, linguistics data do not come as you would expect them to come. What is more important is that linguistics data, though comes in like speech and in sentences and in paragraphs and everything, it's a systematic information. So because you are focusing on noun phrase does not mean that the noun phrase does not say anything about the knowledge of these people. Because an English speaker would say black dog, a Yoruba speaker would say dog black, right? Saying something very important about how we view things and how these shape our thinking, at least to some extent. So data is what? A systematic representation of human knowledge. Linguistic data is an extracted form of this data that we get from elicitation process. Brilliant. So what are the characteristics of linguistics data? It's an output of your data language documentation. You're writing a paper. It's the output. It's part of what you use to drive your argument. It's empirical in nature. It is finite but powerful. You would not see a linguistic paper trying to dumb 500 sentences to explain a fact. It is always the case that we have a fact and we need just finite number of data to drive this specific research, right? So it is finite, yet makes infinite number of predictions, just as you see in the finite state machine. It describes patterns per time. Every aspect of a linguistics data is describing a pattern. Either it is one pattern at a time, either it is two patterns at a time, whatever it is predicting something. It is describing pattern. It predicts the grammar of the language. So apart from the fact that we can make prediction, we can predict grammar. Grammar now is rules, the permit, if it is phonology, for instance, the phonotactics of this specific language, the transformation, everything that is going on per time. Now it tells us the hypothesis space that we are trying to take care of, the size of our n-gram. It's a powerful constraint on our description. So our descriptive generalizations are not just description of data, they are the descriptions about the constraints on what people are doing with their language. So it's the description of the language, but in the other end of it, it is the constraint on the description. I hope that is clear. So now, what is the difference if you have like a linguistics data and a machine data? So as I said earlier on, a linguistic data set is what? Finite, powerful, deterministic. It is pattern. Everything is descriptive generalization. For example, a language A only have B as its consonant. That is an in-language generalization. That is a rule. But a description like language B is an SVO language, is powerful. It tells you the position of the subject, the position of the verb, and the position of the object. If you are doing like a part of speech tagging in NLP, a part of speech tagging would take into consideration the position of these words, the NP, the VP, and the NP, whatever DP, whatever you want to call it. In a machine data, the goal nowadays, I mean, in this modern large language model and everything, is statistical. And because it is statistical, you need a lot of data points to reach your conclusion. Now, one thing that is now important to note is that machine data is a flip of a linguistics data. Remember that in a linguistic data, we have facts and we have finite data describing this fact. In a machine data, they don't have this fact on the surface. They would have the data and the data will have the fact. So what should actually be is that it should be a collaborative effort where we have the fact, but because you want to scale your work, you use our fact to build your data set, right? So linguistics go from finite and make infinite prediction. Machine is having infinite, like 500 million sentences and trying to reach the same generalization. Remember, language is finite. Finite in the sense that it is learnable. We can learn it. It is learnable because it is finite because we can learn it. It is learnable because it is finite, if that makes sense. Now, how do we collect collection of linguistic data? So I will quickly go through this idea that I got from my elicitation process and from Dr. Kimbo's explanation about data collection. So it is a process of acquiring data. You can use the word list. You will need to break your word list to part of speech. For example, if you have a noun, then you look at the morphological information of this specific lexical item. What is the syntactic description of this lexical item? I know that, for example, a noun in English has number, right? It has a number marker, so it can take plural and singular. English is not so morphologically driven as some languages are, where even you can communicate gender, like in Hausa, you can communicate gender in using suffixes, like Spanish, like all these languages, they can communicate part of speech, gender through morphological information. So you would divide your word list into part of speech. Then you would look at the morphological and syntactic distribution of this part of speech. So when you elicit the words, you elicit the words in sentences. So for example, if you remember that I'm collecting linguistic data and I'm having in mind that I want this linguistic data to go into machine, right? So I would divide my word list into part of speech. Then I would use that I use the part of speech in sentences. So for example, if I have a boy and I have boys and I have like a structure, like the boy is here. If I have another sentence, using the same boy, but now plural, so it will be the boys are here. In a language that has a rich morphology, it is possible mostly that you get some inflectional system where there is a concord. The verb is agreeing with the subject, agreeing with the object, when it is singular and plural and gender. So you will get the plural, singular and plural, singular, male, plural. Sorry, you have, if you are looking at noun, we have the number, that's singular, plural. We have the gender. It will be, if I have male, it will be male, singular, male, plural. Female, singular, female, plural. Then before you know it, you have, for one lexical item, you have multiplied your data set. And what happens is, most of the time, linguistics actually, we have word list. Even if you look at about the 400 word list that we use, or you look at the SIL, Summer Institute of Linguistics word list, it has about 1,000 plus, it has 1,000 plus word list. If you multiply 1,000 plus word list by 7, you get a lot of data. Remember, the goal is to scale your work, right? And in fact, this particular system works even well for linguistics, because with these different permutations, then we can get different ways of seeing the data so that we can collect every possible combinations, right? You can use themes. This is what I've done in the past. If I have a task, for example, even if you are doing a part-of-speech tagging system, that's part-of-speech tagging is when we want to tag each word in a data with their part of speech. Is it verb, is it noun, is it everything? Because sometimes the structure of the sentence that I'm using this word list in, it's very confined. It seems that I'm just repeating the same pattern. I can decide to say, I want to go education. The register will change, right? I can see pupil, I can see class, I can see board, I can see a lot of things that would change what you will get in a typical word list, right? And then that will make it easier for you to vary your data collection process. I can do technology as a theme. So whatever the task may be, I am looking at technology and I'm doing like phone, like internet, laptop, like, gadgets. I can do finance. I can do something like money. I can do exchange. I can do a lot of things. Even though I can be doing that with a word list, I can still vary it with the structure, the sentence I am collecting it from, because then I'm using different words and they're registered words. And in fact, sometimes some NLP, some AI research is mostly within a specific theme. So you are trying to fine tune for a specific task. You can use narratives and storyboard. For example, you can use burial rights. So how do you do burial rights in your language, your marriage rights, the folk tales and the folklores? Very important. So you collect that narrative and then you can build that into a data set. Again, in fact, this data set can be talking about cultural data sets. Most of the time, even this AI research do not focus on the cultural nuances of the specific group they are eliciting, they are collecting the data from. So with narratives and storyboard, you will not only get any data that you can see online, but you get some hidden and very important data. Remember that data is what? Expression of knowledge system. So, all right. So you can have frameworks. It's the framework in this case is like the environment of a phenomenon. For example, if you want to do headedness, you can use phrases. So if you want to do headedness in this language, you want to know how these people are thinking about being head, the head of a structure, you can just do noun phrases, right? You can even use phonology frames too. For example, most of the time, if you want to see associative constructions on tone, if you want to see tone, floating tone, basically, you can use associative constructions. You see that the behavioral pattern of this tone mostly change if you begin to have associative constructions. Uh, if you have like a vowel harmony, you are doing harmony between either consonant or vowel, you know that when you're doing harmony, you're looking at least two things at the same time. It's a frame, right? You need to collect your word list and break that down into a frame, put that in a sentence and see how they're behaving. You can have semantic frame too, in terms of maybe different affixes because of different noun class system. or the fact that numbers are expressed in different places. Can narrative be collective in lead, question, or interview format? Yes, it can be. It all depends on the purpose, right? But for an NLP process, a conversational AI, we'll still talk about this later. Conversational AI task is how linguists can actually build data set for uh, narratives. So we can have paradigm. So this is like you are contextually eliciting some things. And what is very important with paradigm is that you have the same structure, but you are focusing on one thing at a time. If you look at the pronouns, if you want to elicit the pronouns in a language, notice how I said I see Sam, you see Sam, we see Sam. Everything there is see Sam, see Sam, see Sam, but there is one difference, which is what? I, you, and we. So in this case, what you are trying to do, you are trying to elicit the pronoun system of the language, right? So you expect to see some similar forms, there should be one change. So you make your analysis systematic, even though you are building for machine. Now, there is a trick. If you want to encode time, most of the time you can use yesterday for past, you can use will and tomorrow for tomorrow precisely for future. There are many tricks to this, but this is just how I will put it down. So this is a paradigm, a pronoun paradigm. You can elicit distal and proximal entities by creating pointers. I don't have any here, but if you want to elicit like I saw them there, I saw them here, you would have to prepare your slide in a way that it would show different pictures. You have a point and you have a direction. So if I have A here and B there, and you start to play around these things. When you are doing this, you are not only you have a pattern in mind. Remember that linguistics is not just throwing the data away. We have a pattern. I'm expecting that there is a way they will be marking their distal, for example, and there is a way they will be marking their proximal. Even though this might lead to now 500 sentences, I had a goal in mind, and that goal is represented in the data, right? You can add stimuli. So what is a stimuli? You can call it carrier phrases. They're just like if you are not sure about a phenomenon, for example, you are hearing a sound that you've never heard before and it's looking really strange. You try all things to try to listen to it and you try to do the pattern. It's not just adding up. You can use stimuli to elicit that. So it's very common in phonetic studies. For example, if you want to know the format values of a given vowel, you will need to vary the vowel, along different sound in the language. You have to have a control. For example, what does the vowel sound like without other things around it? What does it sound like if you're looking at R, for example? What does R sound like uh, before a given number of consonant that is in the language that you are considering? And what does it sound like in other combinations? So you expand this, but in the process of expansion, you have created a statistically rich data. Remember that that data is now a chain of thought that is representing one thing. For example, format values, right? It's different from when I have this data, I don't know what they are, I don't know what they are doing, then I'm trying to find the pattern. So I feel like if we have the finite point, we know what this thing is all about. It's easier to instruct these machines on how they could learn from the data given to them. So what is descriptive generalizations? I'm going to be resting more on what McCarthy explained in doing optimality theory or something like that. He said the essential gap between data and analysis is your descriptive generalization. The essential, I'm trying to read a question here. How can a machine be trained to understand and interpret cultural nuances of language, especially for translation purposes? So yes, as I said earlier on, if you are looking into cultural nuances, you are collecting narratives, right? Burial rights, marriage rights, birthday, celebration, um, festivals, everything, all these cultural things, then you would need to have a type of data. So if you are doing translation, It means you are doing parallel data, which I think we had the discussion in one of our classes from Nathaniel when he was explaining the bytext, the by more to text. So you would have what we call parallel corpus. Unfortunately, or fortunately, we didn't go into corpus in this particular summer school, but maybe in the future, if we're able to organize something like this, we'll talk about corpus. I think I've given a lot of teachings to on corpus linguistics in the past. So you are dealing with first, what type of data is it? This is a machine translation system, and you need to have like a parallel corpora. So a parallel corpora means that you have a data set that has the same thought in different languages. So for example, if I say I am Samuel, I can have I am Samuel translated to Igbo, translated to Hausa, Swahili, Lingala, whatever language I am working on. So if it is a narrative, you know what I mean? It means that when I get the narratives, I translate the narrative to what? To English, to Hausa, to Igbo. Now, how do we then teach machine to do this? We teach machine to do it because machine would need to understand this data and how it can translate it to other languages in terms of translation. I hope I was able to answer your question. All right, so descriptive generation is the essential gap between your data and your analysis. And you must find a way to write a very strong descriptive generalization. It says they are accurate characterizations of the systematic patterns that can be observed from the data. The systematic what patterns? Remember that I said that actually what NLP or what AI guys are trying to do is to find patterns that linguists already created. So what I'm doing, what I'm trying to get at is that we should actually have a system of data collection, especially if you're doing supervised learning, in a way that flows from the patterns linguists have discovered into their machine system. Because with that, we don't need billions of sentences to reach a conclusion, given that we are looking at a specific systematic pattern in the language. McCarthy said, any competent linguist who sees the generalization but has never seen the data ought to be able to invent data that are completely consistent with the generalization. So I personally am very, very interested in descriptive generalizations, too much that I barely care about the theory. So whatever the theory you are using, whatever means you are explaining, whatever level of linguistics you are, whether you are doing semantics, you are doing syntax, you are doing phonology, whatever thing you are doing, you must write your descriptive generalization in such a way that any linguist J can see it and provide hypothetical data for it. So if I tell you in Yoruba there is no coda, yes, I know what coders are. I can give you BA, I can give you DU, I can give you KO. I should not give you AB as a plausible constraint or as a plausible form in Yoruba. So essentially, if you write your descriptive generalization well, it should flow into how much data I can give you. In fact, it now makes a finite number of predictions about this language, right? Yoruba, if you read this generalization, let me give you the look at the last generalization that I gave there. Many Niger Congo languages are SVO. Okay. Many Niger Congo's languages are Niger Congo languages are SVO. So I'm thinking, okay, you mean that I must say Samuel before I say eat, before I say rice? That's kind of generalization, very concise. But I think the second point here from McCarthy, please, if you don't take anything, pick that up. Any competent linguist who sees the generalization but has never seen the data ought to be able to invent data that are completely consistent with the generalization. I keep bringing this thing in my head every time and every time I try to write something, especially in phonology. I must be describing this thing providing this line by line such that if I give it to anybody, they can supply hypothetical data to whatever generation I'm reaching. So how do you construct a descriptive or descriptive generalizations? So this is my own coin. I don't know what you think about it. I call it existential criteria. A language has open syllable only when the last consonant is not a syllabic consonant. Actually, is what I want to say there. I think that's a mistake. It's not a syllabic consonant, and I'm referring back to Yoruba. So existential means that what is in existence and what is the crux for the existence. Look at the second one. A language deletes final vowels except when they are preceded by a consonant. So you have the consistent form, then you have the exceptions. You have the consistent form, then you have the exceptions. Then you have the consistent form, you have the exception, that existential criteria. Now I add this existential criteria is important because they focus on one thing about this data. Now, what is striking is that when you vary this, your generalization across different words, remember that when you have your words, you want to build statistical data, you put them in what? In context. And I have explained that you can use your theme to create different contexts. You can use even your narrative to create different contexts. You can have something more general. A language has SVO. If subject comes first before the verb and the verb before object, except the verb is inflected for the subject and the verb. So a language like this Italian, or language that can inflect for subject and verb, you don't need to have them present. But otherwise, you would have an SVO language, right? A negative marker comes before the main verb in language, except when the subject and object are absent. Then you don't even have a sentence, right? As powerful as these generalizations are, I have shown you a sample of how you can construct it. You have the consistent generalization, you have the exceptions. They call it optional rule. There's a paper, I think earlier this year, that explained optional rules through statistical probability and all. I think it was written by Huan Tang or Teng Dai or something like that at University of Michigan. You can check that out. Now, how do we go from description to statistical data set? Very good question. So you pick each patterns, you make them into a data set. So I think this is where I want to write. Oh, yeah. I hope I didn't rush too much anyway. I kept this really simple. So, but I want to illustrate. So I hope you can see my board and it is not upside down. So let's do a very simple exercise. If I say, let's look at CV. So a language only has a CV syllable. It does not have a VC syllable. No VC, only CV. Simple phonological description. How does this feed into a machine? Now, if you are building an ASR system, it means that if you are training, you provide the quality, you know that the effect of what you are sampling is going from right to left. Don't forget, in phonetics, the shape of consonants, or most of the time we determine the shape of the consonant by the consistent value of the formant system. I mean the vowel, right? So this is a language. So I know that this language, I can only have ba, I can only have ka and all like that. Then I know that I can pick this and make it into a sentence. So let's say I'm using this frame. Let's say a ba ka, a ba sha. Let's say this one is I ate, rice. So then I ate, so I need a system where we have the plural, the frame, we have these, and we have that. So I keep populating these I keep changing that. Now, there's something called synthetic data, and I will try to just put it in here. Now, a synthetic data set is when you have a data set, but the data set is not enough or it's not statistically enough for your work. I think we'll cover that tomorrow. You can bootstrap. So bootstrapping just means that you want to populate this finite form. So, for example, I can have the same sentence and begin to change one thing at a time. I can change this you to you. I can change this to meat, right? I can keep going on in this frame till I reach whatever I want. What this says is statistically term is that if you have a true value, a true mean, if you keep mapping the same thing at the same time, you would always have the same mean value. I'm saying that if we bootstrap this into a synthetic data using this generalization, I mean, if you're just like changing this form, it will not affect this bar in any way. Our descriptive generalization is still constant. That is one. So supply all sentences or phrase that contains generalization, vary the specific generalization over the morphological and syntactic distribution. So for example, if I have this, and this is a verb that needs two things, the person eating and the eater, right? I can look at the morphological combination of this. So what happens to this when I have bar? What happens? What happens to this when I have anything here? That is the phonology. Good. Let's look at morphology. Imagine that this language actually has prefix system or the suffix system. What happens to this, my generalization, if I have a prefix, say a sha? What happens to the generalization when I have a consonant as a when I have a suffix, say ta? What happens? What happens to this guy? So while you are focusing on one thing per time, you are populating your generalizations across different means. Now, because we are focusing on statistical data, and because we know that the normal distribution, saying that no matter how we pick anything, no matter how we populate our data, we are saying the mean value would not change. It will be updated as we move. So as we bootstrap from specific generalization, then we would create more data sets. And one thing that is important is that you have not changed your generalization. You have not done anything to it. All you are doing is just to vary. You have to permutate it, and you have to do a lot of things. I actually have something on that I thought I don't know where I kept the material about how you can do permutation and combination with linguistics, like something very similar to factorial system with the optimality guys that provided like an factorial system. Now, apart from these generalizations, you are actually you actually have a lot of data set before now. Remember that you have collected your words. The words are data. The sentences are data. Apart from the fact that now you have a systematic pattern that has been designed to keep populating your data set with, you have more data sets than you can ever imagine. So, for example, you can be working on phonology. You can be working on syntax. So in this language, you cannot move when you are a subject in a complement phrase. Like if I say a, let me go back to my hypothetical example, a basha. Remember, this is I ate rice. Then if I have a, let me, la, trying to design this thing in a very simple way. I can say a, ba, sha, la, Tom. I ate rice. Who? Now, I mean, who is tall? Like just hypothetically, right? So now I cannot say it is it. I cannot say sha a ba la Tom, because then I'll be moving this thing from a complementizer. I mean, let's assume that this is what you're trying to do with syntax, only syntax. Very good. Now you want to begin to vary this data within different possibilities. So again, you can resume back to your theme. Okay, this is rice. What is this? This is food, right? Nice. Can I have answers? Can I have phone? This is what? Tech. Can I have, I mean, different teams, right? Can I have like board as in class? This is education, right? While you are varying this specific number of contexts, you have also achieved your frames. I mean, in terms of populating your data set with this generalization. Now, let me quickly connect one or two things here so that it makes it easier for us to see. You can change your view now to my slide. I want to quickly explain this. I will call it a day. If you look at how do we now connect these things? When machine data guys are doing things, they work with tasks. I actually think that if they don't work with tasks, they work with linguistic generalization, they might be better off, because then they are focusing on one pattern, and the patterns are async, the way the machine learn, because the machine already the pattern is consistent, it's not just random, right? So we can see sentiment analysis. So sentiment analysis is when you try to know the sentiment that is behind a communication or behind a proposition. Um, many many of these works have focused on having um, text in terms of positive or negative, and I think I explained sometime, I don't know whether it's here, that actually phonology, phonetics, and everything like that also contribute to how we perceive sentiment. So if I say, should I eat the food which I have eaten, if I've eaten before, then and I heard that and I was given a permission, I must read in line what the permission actually mean, right? So that is a form of sentiment. So it can be sarcasm. I just gave it as a sarcasm, and it can be negative plurality. Like I did not eat. It's a negative sentiment, right? That is going straight to sentiment analysis. I can have what other research and their functions as part of speed tagging. What is the distribution of words based on the context, the polysemials, and everything like that. I am doing like a part of speed tagging task. If I want to have naming system, onomastics, that is named entity recognition. What do you call rise? What do you call this and that in your language in this data set? So that can come from what? Narratives, right? So we call a newly wedded husband angle, or we call it this, we call it that, we do this, we do that. From there, you are building a name entity recognition with its systematic and very cultural. Sometimes, if we read these name entity recognition issues, most of the time I feel like we focus on named entity, anything name, so much that even if you have Yoruba, it is a translated naming system into Yoruba, which we know it is wrong, right? Because the way and the reason language B would name something will be different from the way language A would do it. Why? Because it is a means of communicating their belief system. It's a means of communicating who they are. Another example is intent and entities. Intent an entity is a kind of data set mostly for chatbots. Either you are doing conversational chatbot or everything like that. And I actually think that this is an argument structure. And what does it look like? You remember what an argument structure is? You have a verb and its argument. Now, the verb and its noun. So the entity, the intent is the verb. The entity, which is the noun, the entities are the noun. So if you have an e-commerce data set and someone say, okay, we want to build an e-commerce data set, think about it as what? As an argument structure. So I have different arguments. I want to see how they relate to each other, and I want to see how much order they are making per time. I want to order rice. In that case, you have order, and you have I, and you have rice. Now, what is striking is that you can actually compose your argument structure to predict the number of or the type of entity that is around it. So, for example, if you have a verb like je in Yoruba, je in Yoruba has different meanings. So, Yoruba, the word je, this means to eat, but this can change depending on the context you find it. So, if you eat food, if you eat someone's eye, I mean, I'm giving this as a transliteration. So this one is if you eat someone's eyes, it means that you chop their eye, if you understand pidgin. So this one is you chop that you didn't care, like you treat you treat them in a way that like you don't care about their feeling, you just treat them anyhow. So and then this jet can keep varying, but then what is very striking is that the structure of this jet will remain the same. Why? You must have someone that is eating, call it A, something that is being eaten, call it B. And this structure is the same. Even though the semantics, of course, will vary, if you are building an internal entity system, what you need to master is the fact that this is one thing and other thing can be predicted. Whether you know the meaning or you don't know the meaning, the structure is independent of your intent. Remember, intent and entity is like the action and the noun, what you want to do. I want to order rice. I want to buy book. I remember the one of the first dataset I worked on when I was working at a company was to create an internal entity dataset for Yoruba, and then they gave me an internal entity of English, but I had to explain to them that it won't work this way because semantically the meaning begins to change for different purposes. But of course, I agree to the fact that what the structure is the same. So what I'm saying about the structure similarity is that if you go back to the board, I'm writing on the board now. If you pick a transitive verb, you can group, for example, you can group all your transitive verb as the same. You can group ditransitive verb as the same. You can group intransitive verb as the same. So the structure of your data set will keep varying based on the type of verb you are dealing with per time, not based on the fact that you have intent. So with linguistics, we have been able to fine-tune and give our data set a finite. So you're looking at three things. For example, let's say transitive, ditransitive, and intransitive. There are millions of sentences you can keep generating using the verb and their argument. But then you are grouping these verbs into different types, and this one in turn inform how you change the entities, thereby creating a statistically rich machine data. Now, creating and connecting cultural values. So, for example, we do social linguistic variables as multilingual data set. So, if you have heard me explain, if you know, many people would say that if you are a native speaker of Yoruba, everywhere you see vowel initial, you call H, right? I have heard a lot of people say that. That is a social linguistic variable. Is that not? We are marking the fact that when they see art, I mean, not everyone, right? But this is a stereotype. This is a social linguistic stereotype. What they say is that you hear them pronouncing heart, right? Now, why this will be derogatory in some sense? This is saying that this is a social linguistic variable, marking a Yoruba speaker of English from like an Igbo speaker of English. In Igbo, an Igbo man will say develop. We will not say develop, right? Because the Igbo language has a vowel harmonic system that is strictly harmonic in nature. So when an Igbo man thinks about develop, something like this, and he knows that he doesn't have air, for example, right? He doesn't have air in his language, but he knows that this thing is, it should be harmonizing in some sense. He said develop, develop. So it's not random. It's a social-linguistic variable systematically explaining how these guys are doing what? Representing their language. So why this might look like, okay, they are saying these guys can't pronounce well. No, that's not the case. It is marking, it's a social-linguistic variable. And what is going on right now? What is going on right now is that people are doing a lot of multilingual data set, multilingual data, multilingual learning, multilingual what. But I'm happy to tell you that linguistics is actually the heart of multilingual learning. What I mean is that with linguistics, you can systematically collect multilingual data sets by focusing on one variable, social linguistic variable at a time. So if you have narratives, for example, narratives are conversational AI data sets. Somebody asked a very brilliant question the other time, can we collect narrative in can we collect narratives in terms of question interview session? That is what narrative is all about. 2, 3 people trying to talk about something. You are narrating history, you are asking questions. Machines are trained on narratives. So with this finite point and with many things they can map to, I hope I've been able to show that linguistics is the heart of machine systems. Do you have questions? Questions? Questions?
Yeah,
Yes, doubt.
thank you very much. I was supposed to have raised my hand before asking question. I'm sorry for that.
It's okay.
Thank you very much for this session. I don't know, maybe in the future you still plan to cover something. Maybe I can ask, probably if it's not part of what you intend to cover before. When you were explaining, I don't know the slide number, you have removed the slide. Well, I'm actually very interested in how you train a model to learn some pattern, like when you gave example of different construction or similar construction with different pronoun, right?
The paradigm.
The paradigm. Thank you very much. So let's imagine that you want to teach the model to say, okay, if you see the first paradigm, this is what it means. And then when you see the second one, this is what it means. And the third one, this is what it means. And then you have more or less like a conversation. And then you give the model that conversation. And then to find this pattern, to be able to reiterate and then maybe estimate percentage of this is available and the other one is available. I don't know, maybe you can walk me through how you actually do that kind of steps.
Yes, very good question. Very
Thank you.
good question. Yes, I love that question. So, if you have a pronoun system like this, I would take Igbo, for example. Please, I am not Igbo speaker, so I will just hypothetically be talking about Igbo. Hypothetically talking about Igbo. You know that in Igbo, the stem is stem control, right? So you split the harmony. So I'll talk about harmony now. So let's say I am eliciting this paradigm. what I'm looking at, the pattern I'm looking at is harmony. This is the constraint. This is the grammar. This is what I am focusing per time. This is how I want machine to learn. Now, I have I and C. So I was thinking, I'm thinking of one Igbo data in my head, but see, forget about Igbo data. Imagine this. Notice that what is here determines what is here, determines what is here. So what does the machine need to learn? What do you think it needs to learn as a pattern? If the shape of this guy is available, insofar as I can detect what is here, so I don't need to train my machine to learn everything that has this frame. I only need to teach my machine the quality of vowel in this particular verb. So if I change this vowel, so in Igbo, for example, let's say you have C. I think this is cook. I don't know. I think it's to, you know, is it? It's the one with the dot, right? I don't know. Like, let's assume this is to cook. Like this C, like this. Like you have this dot under. Or let me just put it as a phonetic symbol. So if this one has this frame, good. But what is determining this frame? There are two things. One, the quality of the type of vowel. Remember the type of verb. Remember that we have ditransitive and everything like that. The argument structure. Number two, the output of the argument structure. The form, the particular thing. So if this is an RTR vowel, this is a retracted vowel, I'm supposed to have O here and not O. And how does this influence the shape of things? That, so take this as a morpheme, like just say not, let's say negative marker, let's say something like re, right? Igbo would have re as in retracted tongue root. So the form that comes out, even though I have identified the type of verb that this is, it's determined by the quality of this vowel. So when I am training my model, I will give my model this pattern. This is harmony. This is different data set. So I will create this data set by not considering the shape, by not considering the type of verb, the type of its argument, but mainly by considering the quality of the verb, of the vowel, sorry. Then it learns this quality to predict this. It's learned this to predict this, this to predict this, this to predict it. When it has learned, I can give it or and re, for example. It will not give me C as in E, which is ATR. It shouldn't. It should give me A, which is the retracted tongue root, based on the frame it has learned. So if I am crafting my data, and I am trying to let a machine learn Igbo, it shouldn't be learning anything. It should be learning the systematic phonological systematic patterns, descriptive patterns. So my description is that a plus ATR or a minus ATR vowel will need to take a minus ATR subject clitis, except it is a plus ATR vowel. I mean, let me state my generalization in that way. That generalization is what machine would need to predict the innumerable number of sentences in Igbo. It doesn't have to know the structure of the verb, for example. It just needs to know the type of vowel quality in that particular position. I don't know, maybe I was able to provide a little bit of answer to insight to your question. And if anybody knows more, I mean, you can omit yourself and just say. So by model or machine, are we referring to a particular software or the device itself? Oh my. So I said model is something that is predicting, something that I've learned and is being fitted in and it's predicting something. It's giving us an outcome. It knows it has learned something and it's giving us outcome. Dr. Onyinye.
Okay, thank you very much. Please, I want to know, From training the machine, you mean by giving it descriptive, patterns or generalizations, right?
Mm-hmm.
That is one. Then now, descriptive generalizations, how you put it there now. If I want to link it to the other lecture we had earlier, I want to ask, is it always in this sentence form, or we need to now build in when we are doing now the formal language learning? I want to know how we build within the sigma, within the variance. Can we have features there, or is it just numeric?
Yes.
And
Yes, we
we
can
can
have
do what?
features. We can have anything. We can have what it depends on what you're doing. Like there is a paper I can share that later by Magda at Stony Brook University. She does that. She
Okay.
uses features where there's only one feature changing per time, and that even streamlined. If you are doing like an ASR system where you're trying to understand the vowel and the consonant. I mean, just you are doing acoustic model, not language model. You are trying to just spit out the phoneme to the grapheme. You are looking at the quality of this vowel, the sounds. Yes, she does something like you can just change this feature and it will give you that. Yes.
Thank you.
Yes. Do you have another? I think you had another question, right? No?
I will just, sorry, should I continue?
Yes, Ma, you can. You can.
Okay, so um, I'm wondering now, so when we say we want to build a final state machine, is it that, like the example you gave in Igbo, we have different variables, like you said, we can always add and add and add, to maybe get different things added in our collection. I mean, so if I'm doing, and also you made mention of the language linguistic data describes a pattern or patterns per time. So how do we marry, if we are trying to build generalizations, how do we marry these different behaviors into one? Or do we build different algorithms for each process and then now kind of work them into a final state machine? I want to understand.
Yes,
I don't
so
know if
if we
I'm
have,
making sense.
yes, I think if you have, let me, I don't, let me try to uh answer. If I am not answering what you are asking, then I think I didn't get you well. So I think what you are trying to say is that if we have different patterns, different generalizations, and we will need to, are we creating two finite state machines for them? And let's say you have two generalizations now. Let's say you are talking about the syllable structure, you're talking about harmony, for example. Now, how does this now feed into your statistical data set you are trying to generate? Yeah.
Exactly.
Okay, so as I said earlier on, I said that the rules of languages are finite. A language A does not have 50,000 rules. It's not possible. That is what you might insinuate, or that is a wrong inference you might make if you are giving it billions of sentences, thinking it's going to come up with like 5,000 uh, rules. Of course, it depends on the task, depend on what you are doing per time. In this case, I'm looking to, let's say, vowel harmony or something like that. Okay, so if you have like a syllable structure rule, you will create a finite state. You will create a finite state machine and you can concatenate them together so much that it's giving you just one thing about the phonology of the language. That is a little bit advanced, and I didn't go there at all. All I am doing is just to show you, in fact, introduce finite state acceptors and finite state transducer in as I mean in as simple as I could. And where I was actually trying to go to, I'm not sure I'm able to actually do that now, is to show you how to do multiply eigenvector and eigenvectors as they relate to finite state machine. I can get that from a finite state machine. I can multiply it, and then we'll go into the supervised and supervised learning theoretically. Then you see what machine is trying to do is that they're trying to multiply this vector, and how we create like one hot code analysis, which is how you can represent or embed your textual data. So yes, each of those generalizations can merge into two things when you're creating them into statistical data. For example, even though I know that I am varying syllable structure, I can still be varying the harmonic pattern. For example, I can change the C to seed. Let me just give you as an example, right? Or C to sip. with a CVC structure, and maintaining the idea that I would expect this clitic, this like negative marker and the subject clitics to be varying based on the quality of the vowel, and it is still making the same descriptive generalization. Making descriptive generalization, I mean, like, I can look at what you are doing and provide a hypothetical data set to feed it without seeing your data. Professor Samiat, you raise your hand.
Thank you very much. Thank you so much for this clarification you are making for me, because this ending on the question I want to ask. I've collected my data, maybe using the 400-word list. And I decided that, okay, I don't know all this long process of training the machine, and my ultimate purpose is to get the machine enriched so that when I go to it, I can get sufficient translation that will satisfy what I want. How do I proceed from where I am now? Because I've used the 400-word list, I've used the Summer Institute of Linguistics my document to collect data on a particular language. And my purpose is to make sure that I want to train a machine to be able to reproduce in the languages that I want to work with. How do I go about it?
Thank you, ma'am. So, and in fact, you have created a machine translation data set. You see, one beautiful thing about linguistics language documentation is that what we are documenting most of the time, where it shouldn't be, right? We go from one language that we know to another language. And if you are annotating in Elan, for example, you know that when you are annotating, you annotate the language by translating your voice, right? So, for example, if I'm collecting data in Igbo, and I am using English. If I ask the Igbo man, what is head? And he say easy, I would select the portion of the easy and translate the head first. You know what that has done? What that has done is that when I create my TAs in Elan, I can export the head, the item of the head and its translation, and put that into a parallel corpus, like export it as a text file. That alone is a parallel corpus. Now, how do that feed into this paradigm? Very good question. The first question is that, is this an undocumented language? If it is, you don't know anything about the grammar of this language. That's brilliant. As linguists, what do we do first? We find patterns. We try to understand the data. Now, let's say all I have found is this language do not have, what kind of thing can I think of? Okay, this language is gender heavy, like it marks anything gender. So like German, for example, German has heavy on gender, it marks everything. So let's say it's use A, B, C to mark gender. So like male, female, and neuter, or whatever thing they want to call it. I have found that. That should inform how I will begin to frame my question. So if I am eliciting paradigm, like I am here now, I know that I want some masculine and feminine. Let me give you an example here. So look at this. I know this is mass, this is F, and this is neutral N. So this is MFN. So if I see Sam, I have a constraint. I have a discrete generalization that says that the Sam here can have different form. Based on this, I have a means of multiplying this by 3, right? So I can see, oh, we don't have a female Sam. So let's assume we have goat. So I see she goat. I see he goat. I see neutral goat. What I have done is I have picked one thing, I have multiplied by this, and I've got focusing on just one thing by this pattern. And I can keep going like that till I have enough. Now, the question is, what are you aiming at? So one thing I didn't mention, if you're working on a project, like I work on a project, I work on projects and they ask me, they don't know, these computer guys don't know. They say, okay, we are training this machine and we need like 1,000 training sets, 300 test set or something like that. There is always a target. Nobody will tell you, let's build data sets and we keep building. I mean, to what extent? So when you know the size that they want, that will enhance how much you multiply your data set, right? By the theme, by every means that you have. If they are creating like a million token, type and token are different, right? A token is the total number of counts in your corpus. The type is total number of unique items in your corpus. So if you want to create a million type, which I have been thinking anybody would think about, if anybody is here, you want to create a type, imagine you have a data set and you have 1 million unique data set, a unique type. So one thing that is very important, the type is how we introduce new information to machine. The token is how we strengthen the pattern. I will say it again. The type is how we introduce new information into machine system. The token is how we strengthen it. So for example, look at this data that I created here. The very good thing. How many types do we have in this table? How many types? We have I1, C2, goat 3. So we have 3 types. We have 3 types. Now, if these were to be different forms, I mean this E and everything, then we would count them as one type. So this is 3, and then we have 4, 5, 6. This is 6 type. How many tokens? We will count everything. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 tokens. Now, why is it introduction? Now, every unique word will provide new information. Machine begins to wonder, perplexed, confused. When it now sees these tokens, it begins to learn the pattern. So in a way, a type is linguistics pattern. The token is how machine learn it. If that make it easy. So have you thought of creating a data set where you have 1 million unique words in Yoruba? That'll be a very interesting project. I would love to see, or whatever language you are doing. If you check all the internet, what we have is we focus more on tokens. But tokens are not providing what? New informations for machines. It is only strengthened because it is within, okay, take tokens as like frame, like a concordance, like your sentence, where you find a specific pattern, the loci, the environment of occurrence. It will strengthen it. So it has said something but doesn't know where it is. The tokens will provide a way to see the patterns and can reach generalization. I don't know, maybe I was able to answer your question in any way.
Very, very well. Very well. That
Thank you,
means
ma'am.
I still need to learn more, and I will continue. But
Okay,
for
ma'am.
now, I am engaging a computer expert. We actually it's a collaborative work, and we have decided that okay, those in AI department, they should take other aspects. I have collected the data, and I think what I just want to do now is to do what we do in lexicography, make a dictionary of it and keep, because that is the extent to which I think I can go from my present knowledge of all these specialties. So I think I got the answer you gave. Thank you so much.
Thank you, ma'am. Do we have other questions?
Ma, what are you doing the dictionary with? What app are you making the dictionary with? May I ask?
Okay. Thank you very much. There is a particular one that a colleague usually use, and that is the what's the name?
LexiPro.
LexiPro, my dear. Thank you very much. It's Professor Arukoyo that actually taught me, and that's what I want to use. That's what I want to use. Help you understand it. LexiPro, it is just the way we spell. You can get it online. If you type it, you can get it, ma.
That's fine. That's fine. There are others, and
Thank you, please. I want
each
others that will
one-
be more. Yes.
that's sufficient for what you want to do right now. Or Sam, what do you think? I think LexiPro is okay for now.
Yeah. So, but yes, I think before I would say something, I think let me finish this. I would talk about that later. Like, I mean, the means that we can use, but LexiPro should be, if you are comfortable with LexiPro, you can just go out with LexiPro. But there are many things that you would have done with it if you use other tools. But I would keep that till I stop the class. So I heard you say we don't need billions of data sets. Yes, to train a machine. What quantity or amount and quality of data is enough to train a model? That's a very brilliant question. I think it's debatable. Personally, I don't know. It's the amount nobody know, they didn't agree on. It's just like how much the machine can learn, the number of epochs, the ease of learning, and the task per time. But personally, the first statement you said is true. I believe that we don't need billions of sentences to train a model. Why? We're supposed to be moving from pattern and descriptive generalizations to creating statistical data. That's what I have done. That's what I'm trying to do in this particular class. The number of data set, the quality now is very important. It depends on the data. So let's say a speech data. I think you were in the class where Professor Akibo was explaining why we need a quality data for speech. For text, you shouldn't keep your data set with a lot of HTML5. For example, HTML code. So that, for example, if you are working on a data and the data is hinged on the fact that it is filled with a lot of noise. I mean, things you don't want in there, then it's not of high quality. There are a lot of things from corpus linguistics about the quality of data that I won't be able to go on because of time and space. But I hope I'm able to provide a little answer to your question. And do we still have questions before I stop the class? Yes, Dr. Onyinye.
Thank you very much. Please, I also, sorry, I'm taking you back to your former class. About the finite state transducer. I want to find out from the 0 state to, the intermediate state and final state, given the lines and the loops. Is it flexible? Is it fixed? Flexible in the sense that, you talked about like nasalization in Yoruba. If I give my generalization, can another linguist, and I do my transaction from the initial stage to the final stage, can somebody else maneuver it from another way, or is it fixed?
What do you mean by maneuver, please?
Have different pathways to it, or
Nope.
is it?
It's fixed because that is why you have your start state and your end state. That way it is fixed. It is not fixed in the sense that how many set of strings can it map to? That is not fixed. It's flexible. You can keep giving it a lot of strings, and that is when it can make predictions. So if it keep giving you, and when I think there's one thing maybe that is not clear. For example, if we are saying an algorithm is, if you provide like an FST finite state machine algorithm, it's saying that if I'm starting with, we are starting with A. So let's say I have a structure, a bar. what he's saying is that when I am reading this string to string, I read from left to right, and it must be the case that when I am reading one syllable per time, one syllable per time. Who is that?
Yeah, I mean, now that I have that, when I'm going through the first stage to that's the looping, can somebody have so many loops just to maneuver and get the same result, and somebody will just use one loop? Maybe somebody that is more
Okay, I think, are you saying you are talking about margin of state where you can merge different
yes,
things? And
exactly.
well, I
Sorry.
didn't cover that. I didn't cover that in this class. Yes, there are different principles. You can concatenate, you can reverse any operation that you can do on string, you can do on them because they are set of strings. That is true. But then that will not negate the fact that you already have your grammar. You remember your grammar, your phonotactics, your rules, your descriptive. That will not negate it. Of course, you can, or maybe you are saying a finite state that is developed for nasalization in Yoruba can also work for nasalization in Igbo, for example. If that is part of your question, then if it is the same axiom, that it is the same process of nasalization, then yes, it will work. And that is why what makes finite state machine very powerful. It is focusing on one language and one thing per time, but it is invariably making different predictions. So for example, if nasalization only occur when you have the nasal consonant and the vowel are not the vowel and nasal consonant, like I can see Dr. Onyinye, do you nasalize Onyinye? Do you say Onyinye in Igbo? I don't think so, right? Because the vowel is not nasalizing. So perhaps it means that you only nasalize when the vowel is coming after the nasal segment. I'm actually thinking that O will not be nasalized in Igbo. And if it's not nasalized, I wonder why I mean, that is why you can have Onye and not Nyo in Igbo, but I don't want to bore you with those things. What I'm saying in essence is that if you do have that kind of paradigm in Yoruba, it can definitely work for any language if the axioms, the set of alphabet, the set of states, and everything is intact.
Okay, sorry, just one follow-up question. Okay, so does that mean that for the already established Pan-African phonological processes or phenomena, we
Yeah.
can have one
Yes.
final
Yes.
state transducer for it, right?
Yes. That's
Good.
brilliant. Yes. And that is the predictive power. It's predicting a lot of things. I love your questions. Yes, that is true. That is true. So I want to believe we don't have questions so that we can quickly rush through the second class. Thank you so very much for coming around.